Well, there may be far too many shades of meaning involved. We have not talked about shades of meaning. Perhaps what we really need is to form a common shared environment. We need something more than just one arrow from one element to another element. We need more like whole environment. And here is, I think, where a categorical way of thinking, category theory way of thinking can come in. So instead of this usage model of making implicit knowledge explicit, so the idea was I can use my own tacit knowledge, and now I can use the tacit knowledge of the other side. Instead of this model, maybe a more honest model, maybe a more accurate model, is something like this. The following model, which is communication of tacit knowledge by sharing, not by explaining. On the top level you can explain. You can say, these are the facts I know, these are the facts you know, and you explain. But maybe you have to share an environment so that what you normally don't know and what the other don't know, that you together cannot know in a way. Together you can learn to use it without necessarily having to know it. If you go to another country the first time, you're very surprised. But if you go 10 times, then you sort of know how to behave and you know how to expect what other people will say. You may still not know it. You cannot write down a formula or an equation, but you can learn to share. So maybe, maybe this is what is really needed. So to sum up for now, there are at least 3 ways to do interdisciplinary collaboration. The first way is to teach each other what I know myself, and that of course is necessary. The second way is to try to teach each other how you think. But the third way is to create a common environment so that you can learn to swim together, so to speak, which you really need to do original research. And here is one example of how I try to create a research environment to swim together. This is already more than 20 years ago. This was a paper I wrote with, together as a collaboration between 8 scientists, 2 astrophysicists, 2 geologists, 4 paleontologists from 7 different institutes. And we talked about comet showers as a cause of mass extinctions. It is about the demise of the dinosaurs. The question, how did the dinosaurs die out? And now we know there was an asteroid, but we found a crater in the Yucatan Peninsula in Mexico. But that was only in 1990 that was discovered. So at this time there were indications of an impact through iridium in a certain layer. It's a very interesting story, but I don't have time to go into that. There were indications, but we did not know whether it was comets, or whether it was asteroids, whether it was one comet or a whole group of comets. So we wrote a paper as a review article for Nature. What happens if a whole group of comets can cause mass extinctions? But we had a very big trouble communicating between people. Paleontologists think in a very different way from physicists, which I didn't know until I tried to write this paper. So I had proposed to be the editor of the paper. So while I was the editor, it was the most difficult paper that I have ever edited in my life. Not only between 2 disciplines, mathematics and physics is nearby, or physics and chemistry is nearby. But if you go from paleontology to physics, there is really a different way of thinking. So for half a year I tried to write bits and pieces, but there was no success. It just did not work. Then I realized what the problem was. Even though everybody was very friendly in sharing what they knew, they could not share what they didn't know they knew. So this was the first problem. They could share the top level arrows, but they had tacit knowledge and they did not know it, so they could not share it. For example, here are 2 examples of tacit knowledge. In physics, The single experiment can decide whether a theory is right or wrong. So you have a theory, you do one simple experiment, and yes or no, very clear. That is why physicists can talk to mathematicians. Mathematics is also very clear. So mathematics and physics is sort of similar on that level. There are differences, but there is the clarity, yes or no. But in paleontology, many observations are needed. And only the combination of many observational results can make a theory more plausible and still not definitely right. If I find a few bones, then I think, maybe this is dinosaur, maybe not dinosaur, maybe this type, maybe that type. Maybe these bones were together, maybe they were different animals and they just came together. And many, many uncertainties. And if a bone is in a certain rock, maybe it is this age, but maybe later there was something which happened that the rocks were folded, so maybe a different age. And each argument is like a lawyer. Paleontologists are more like lawyers. It's a very different field. You have to convince with many, many arguments that you are right. And for a paleontologist, a single argument has no value, only many arguments together. And for a physicist, they cannot understand why paleontologists does not believe their argument, why paleontologists needs so many arguments. So complete misunderstanding. And the reason is there is a very important shift in methodology from physics to astrophysics to geology to paleontology. There are all different methodologies. But the problem is each scientist learns only one methodology. So physicists think science is like physics. That is how science is. And paleontologists has learned paleontology. They think that is how science is. So that was the fundamental problem. And after half a year, when I began to realize what the problem was, I invited all my co-authors to come to Princeton for a long weekend. And we started on Friday afternoon, just talking about our own interests, without arguing, without trying to do anything, just chatting to get to know each other. And then we had a good dinner, and we had some good drinks, and we got to know each other better. And then the next morning, after we got to know each other better, then we started to review why we had so much difficulty in understanding each other. And each person explained what he or she did not understand about the reactions of the other person. So the first evening, we just got to know each other as people. The second day, he could complain, as real people like to complain. And we all felt much better, and we had another dinner and drinks. Only the third day, and it was only half a day, did we begin to write. We needed to know each other, we need to complain. Then we started to write, and very soon we could finish. Because now we knew each other, and now we know what the other people did not understand. So then it was much easier to communicate. So what I learned in that weekend was formal knowledge can be transferred in a formal way, but informal knowledge, tacit knowledge, needs an informal atmosphere, a more playful atmosphere to be transferred by sharing. And it is that sharing which is different from this. This is the more formal diagram. So this is already better than this, but the real answer, which I begin to see then, is that by getting to know each other personally, by having dinners together, by drinking together, by knowing about each other's hobbies and family, and really getting to know each other as a person, then you can begin to share much more effectively the tacit knowledge. So from that time on, whenever I had an interdisciplinary group, I tried to have an informal atmosphere to get people together, ideally in a cafe or in a bar or in a restaurant, a different way than just a formal classroom setting. And my conclusions were the explicit knowledge, the written rules and formalized knowledge can be communicated by writing and by words. Tacit knowledge, unwritten rules, implicit knowledge, this can be communicated at best